right. You did that. You put that. Okay. Right. So we've got half an hour. So we're going really quickly. Okay. Okay, right, we're happy. Are you all 100% fine with what we've done so far? So it looks like I might schedule your assessment for next week, Thursday, if the timetable doesn't change, because Thursday is the day where there's a double period and a double period with the 2 choices with a break in the middle. So I can give the extra time of kids whatever. And so for next week, Thursday, plan for an assessment on photosynthesis and cell respiration. Okay, right, we're happy. Okay, so are you all 100% happy about the structure of a neuron? I'm nearly sitting there for. Okay, you can nod if you are happy about the structure of a neuron. Okay, all right. Now, I'm going to start a new section of this particular thing, and you need to listen very carefully to me. Okay, we're going to talk about synapses. Okay, so what happens is, now it worries me that you're all fiddling. Can you fiddle and listen? Are you able to fiddle and listen? Yes, Mrs. Page, or no, Mrs. Page? You're not fiddling, so it's fine. Okay, all right. So, remember that there is a receptor organ. She wasn't advanced. Okay, the cheese.
She's got a problem, guys. I'm so sorry.
No, she wasn't. So there's Emily and there's Tahir, Tino, Lee. That's Tanya.
Okay.
She's put a camera off, little brat. That's Luca, and that's Sash, and that's other Kelsey.
Okay.
So
Thanks.
I did send an email to her, didn't I? I think I did.
Yeah, but she said something about won't Google Meet go off
Won't Google Meet go off?
when she starts the test. I don't know how that works.
Okay. Let me just quickly send a message to.
Guys, I'm so sorry.
Okay, I need to chat and I need to tell Connie.
You know, they should have had someone to do the online testing.
Okay, so I need to tell you that Marge is also doing it.
Is it?
Because I have this class now, and Marge was there, and so I said to her, that this is what is upsetting me. And so she's also got the class, so then you know that the 2 teachers are there. Okay.
Thank you very much. So how do I know which test they're doing? Must I just go on exam.net and look?
You are. My understanding, and I have to tell you, and Rodney was going to organise this. No, Marge was going to organise this. The 2 communities are also doing it. They're not here today. So the 2 communities are doing it one for example as well. But Marge was going to tell them that they had to get onto Google Meet and they haven't. But they only let somebody know at whatever time. At 9 o'clock. In fact, it was after 9. Rodney actually came to see it.
Yeah, because he came to the organ. I said to him, please go and check with
Yeah,
him.
so he came along and then so we went through the whole Conrad thing, we went through the whole fact that Kelsey's not on. Okay. All right.
I'm so sorry. Thank you very, very much. Sorry for interrupting.
No, it's fine. Okay. See you
Yes,
soon.
now I feel proud of my whole person with this.
Okay. We'll see you.
Thank you for helping, ma'am.
Okay. Right. Okay. So, going. So, remember that there is a receptor organ, which is a sense organ, and when that is stimulated, a sensory neuron, which remember is a unipolar neuron, will transmit that impulse towards the central nervous system. Remember that the central nervous system is made up of inter-relay connector connecting, which are multipolar neurons. So within the central nervous system, there are multipolar neurons. Okay. The central nervous system then processes whatever impulse got there, and it will send an impulse via a motor, which is a multipolar neuron, to an effector organ. Okay, you happy? So, there will be, under normal circumstances, 3 neurons involved in the sequence. There may be more neurons in the central nervous system, but you're only concerned with these 3 neurons. So there is a unipolar sensory neuron, a multipolar relay neuron, and a multipolar motor neuron. Does that make sense? And then an effect will happen. And remember, this is a muscle or gland. You all okay with that? Right, so what we're going to talk about today is we're going to talk about these regions here, there, and there, where one neuron ends, okay, and the next neuron begins. Right? You happy? You know what I'm doing? Okay, guys, do you need to give me some nods or something?
Yes, ma'am.
Okay, all right. Because I don't know whether you understand or not. Okay, so this region here, where one neuron ends, but does not touch the following neuron, that entire region is called a synapse. Okay, so that whole region is called a synapse. And it's important that you know that there's no physical connection between the synaptic lobes of the pre-synaptic neuron and the post-synaptic neuron. Okay, there's no physical touching. So there's a little region there where they don't touch each other, and that is called the synaptic cleft or synaptic gap. Okay, you can call it either synaptic cleft or a synaptic gap, and that is filled with fluid called synaptic fluid. Okay, you happy? Nod!
Yes, ma'am.
Okay. We're going to talk about the structure of the synapse in more detail. So I'm just rubbing that off, and I'm going to draw you a better diagram which shows you in more detail. Okay, right, so you're looking at me and you're listening and you're watching. Okay, so this is a synaptic knob at the end of that presynaptic neuron, and this is a dendrite of the postsynaptic neuron. Okay. Within the synaptic knob, there are lots of little vesicles, which remember you learned about last year. So they are like vacuoles, but really tiny, and they're surrounded by a membrane. And those little vesicles are filled with a chemical, and so that little thing is called a vesicle, and the chemical is called a neurotransmitter. And there are a number of different kinds of neurotransmitters. One, for example, is dopamine, and one is serotonin. And these are probably words that you've heard about. because you know about people with depression might have depression because they are lacking one of those neurotransmitters. Okay, so depending on the neuron being looked at, it will only have one kind of neurotransmitter. It won't have more than one kind, but there are a number of different options depending on where it is in the nervous system and depending on the function of the neuron. So you're all happy with the little vesicles and the neurotransmitters. In addition to that, there are also many mitochondria. So one mitochondrion, because my label line goes to a singular. And I'll put that into perspective just now. Okay. In the postsynaptic neuron, there are little channels that are closed. And those little channels are made of protein. So it's like a gate. It's like a gate made of protein. And those little channels are closed. But it is possible to open the channels and to allow ions to pass through. Under normal circumstances, they're closed. But a neurotransmitter acts as a key. And if a neurotransmitter is able to attach to that receptor protein on the channel, then the channel opens. And then if the neurotransmitter is removed again, then the channel closes. So under normal circumstances, the channels are closed. If a neurotransmitter attaches to the correct receptor protein on there, the channel opens. If that neurotransmitter is removed, the channel closes again. And that's going to be critical for what I'm going to tell you just now. Okay, so you're all happy about the receptors here and the channels.
So how do the neurotransmitters travel?
Getting there. So far I've only dealt with structure. I need you to understand the structure. Now I'm going to explain the process. You okay with that? Okay. So remember when I spoke to you the other day, I said to you that an impulse moves as almost like an electrical current. So impulse, 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 electrical, 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 electrical. There's a gap with fluid. The electrical can't transmit across that gap. So what happens is, as soon as the electrical reaches the synaptic knob, it stimulates some of these little vesicles to move to the surface, and when they move to the surface, they fuse with the surface membrane. And when they do that, they open up. And so all that neurotransmitter is released. So neurotransmitter molecules are now released into the fluid on the synaptic gap. They diffuse across the gap from a region of higher concentration to a region of lower concentration. When they reach the other side, they attach to the receptors on the channels, and they open the channels. And when the channels are open, ions that are in this liquid move through the channels, and they start the electrical impulse thing going again. Okay, I'm going to say it again. So the important thing is that in the synaptic knob, there are vesicles with neurotransmitter.
Now, where is this process found? Like, where in the body?
Everywhere. Everywhere where one neuron connects to the next neuron in a sequence, but doesn't touch it. So it could be in a neuron transmitting an impulse to the brain. When it gets to the brain, that impulse has got to cross into the multipolar neurons in the brain. and therefore there would be synapses there where it needs to jump across. Okay, so all over the show, but especially in the brain and the spinal cord, because that's where there's connections between. So remember, if I put my finger onto the hot plate on a stove, there will be one neuron, one unipolar sensory neuron that is that long, transmitting that impulse towards my spinal cord. So there's no synapses along the way, but there will be a synapse where it goes into the spinal cord. And then if it gets passed up the spinal cord to the brain, then there will be another synapse in the brain. Then there will be another neuron which is going to take an impulse out to my arm muscles and says, "You're an idiot, pick up your arm." Okay. So then there will be synapses between those neurons. You sure? Okay, rest of you. Okay, all right. I'm going to go through this again. In the synaptic knob, there are lots of little vesicles and mitochondria that I haven't spoken about yet. And those little vesicles contain a chemical called neurotransmitter. Remember, there are different kinds of neurotransmitters. We don't care. We're only concerned about the fact that there's neurotransmitters in those vesicles. Okay. Remember, in the postsynaptic neuron, there are little channels that are closed. There is a receptor on that channel, and if a neurotransmitter attaches to the receptor and it's the correct neurotransmitter, it will open the channel. If that channel opens, then ions are able to go through and the electrical impulse starts again. Okay, so when the electrical impulse reaches the synaptic knob, some of the vesicles move towards the surface membrane and they open out and they release their neurotransmitter into the fluid in the synaptic gap. That neurotransmitter diffuses across the gap, and when it reaches the other side, it attaches to the little receptor, and when it attaches to the receptor, the channel opens. When the channel opens, ions go from the fluid through the channel, and that starts the electrical impulse going again. Okay, but now the problem is that the channel is now open. Okay, so now the channel has to be closed again, and this is critically important. Okay, at that stage of the game, when the impulse is carried on going here, the channel needs to close. So what happens is there is an enzyme in this fluid that breaks down that neurotransmitter into little components. And that means that it's taken away from the receptor and the channel's now closed. But our body is amazing. It doesn't waste anything. These tiny little components of the neurotransmitter are absorbed back into the synaptic knob, and they are reassembled and put back into vesicles and are reused. So that the components of the neurotransmitter are absorbed back into the synaptic knob, they're reassembled back into neurotransmitter, and they go back into the little vesicles, or little vesicles are made around them, so that they can be reused again. Okay, you happy with that? That process requires an incredible amount of energy. Not the whole thing, the reassembling of the neurotransmitter and the remaking of vesicles requires a lot of energy. How does the body deal with that? The lots and lots and lots and lots and lots of mitochondria that are here. Those mitochondria provide the energy for assembling those neurotransmitters back again, reassembling the components and making them into neurotransmitters again so that they can be reused. Okay. Drugs. No, not your kind of drugs. Okay.
How do they act as a barrier to stop those neurotransmitters from going through?
So there are a whole lot of different kinds, and some of them actually attach to the little receptor sites, and they can't be broken down by the enzyme because the enzyme's wrong for breaking them down. So this enzyme that is here is always specific for breaking down the kind of neurotransmitter that is here. And remember you learned last year, enzymes are very specific. So if this enzyme has got a structure which enables it to break down the neurotransmitter, it can't break down a drug. So if the drug is there in the receptor, depending on the kind of drug, and we'll talk about this next time, it might mean that that channel stays open, or different kinds of drugs might mean that that little receptor is blocked. And therefore, if a neurotransmitter goes across the gap, that receptor is already blocked, it can't attach to it and it can't open the channels. Depends on the kind of drug we're looking at. So we'll look at a few drugs next week.
So do the enzymes break down the ions that come in?
The?
Ions that come in?
No. The enzymes break the neurotransmitter that is in the receptor. Because remember, when the neurotransmitter attaches to the receptor, the channel opens. You can't have that channel open forever. So the enzyme breaks down the neurotransmitter, and by doing that, it removes it from the receptor, and the channel closes again. Okay. But before the channel closes, the ions diffuse in, and that just starts the impulse on again.
Ma'am, if this doesn't occur in the body, does that make you paralyzed, or?
It's one of the things it could. Okay. And depending on where these neurons are and what the function is of those neurons, it can have lots of different effects. And that we will talk about when we deal with the various drugs next week. Okay, how are your questions doing, guys? Were you okay on those questions? I put the memo. Did you check it on the memo? No. Okay. So what I need you to do for next week. Okay. You've learned page 1, you've learned page 2, you've done an activity on page 2. You've learned page 3 and page 4. Please do the activity on page 4, and I will put the memo on as soon as I remember to do it. Okay. Chloe, are you the class rep here? Okay, good. So Chloe, I'm completely senile. I've got more things to do than I know what to think about. If I don't remember to put it on, remind me. Okay, just send me an email. I'm fine with that. Okay, you've learned page 5, page 6, do activity 6.5 on page 6. Okay, page 7, up until the central nervous system on page 7. You must have learned that far and done all those activities. What's that sad face for?
Oh no, I'm always sad. It's just my face.
Okay. All right, we're okay with that. And this will be Monday afternoon's homework as well. So Monday we're not going to add anything really extra to this. Yeah.
Are you going to be our teacher for the rest of the year, man?
What worries you about that?
It's not a worry, man. Not at all.
Wait for it.
Now, by when should I remind you about loading your oil?
My decision is that tomorrow I'm going to clean the house. It's got 10 weeks of piles of crap. I have to clean it. I can no longer step high enough to get over those piles. So it's a tomorrow afternoon. Is that okay? And if I don't do it, then remind me again. I'm fine with that. I don't care. Okay. So the short answer to that thing is, because we don't know what's going to happen from here on, in theory, till the end of lockdown, I will be a teacher. Okay. Right, guys. Good. Warm.